Assalamualaikum warahmatullahi wabarakatuh. Peace be open to you all. Before I present my presentation about recovery of used engine oil associated activated coal by response surface model of pyrolysis distillation, let me introduce myself. My name is Alwatan from Department of Chemical Engineering, Polytechnic Negeri Samarinda. Now we go to the next slide. This is about the presentation outline. Consists of research background, research gap, problem statement, research objective, significance of research, research methodology, result and discussion, and the last one is conclusion. We go to start the research background. Used engine oil is longer useful and can pollute the environmental because it contains metal due to friction on walls of the motor vehicle engine during use. And it has hydrocarbon that have the potential to be used as liquid fuel. At the same time, the need for fuel continues to increase, but its availability is starting to become limited. Activated coal is a nanoparticle that has activated surface area that can absorb a number of impurities and provide space for the catalytic reaction to take place. Why we use lowering coal to convert the activated coal? Because there is a lot of in East Kalimantan and it has no utility value. At the same time, it's necessary to support downstream industry developed by the Indonesian government. However, the main problem when used engine oil is converted into liquid fuel requires high energy. Dissolved metal are harmful to the environment and combustion chamber, so it requires technology to produce clean and efficiency product. And next, research gap. Several studies have examined converting used oil into liquid fuel, but they use different variable and technique. Some use only thermal pyrolysis, others use absorption using non-carbon catalyst, and others use carbon but from different raw materials. According to my study, the energy use is still high, above the 500 until 600 degrees Celsius. Some metals are still deposited in the fuel oil. The yield obtained is not yet focused their study, but the study attempt to combine absorption, distillation, and pyrolysis. The activated coal is expected to act as both of the absorbent and carbon catalyst to convert used engine oil to liquid fuel with lower energy consumption and ability to absorb the deposit metal impurities. Problem statement. Does activated carbon from lowering coal have the ability to convert used engine oil into low pollutant liquid fuel? How do the thermal effect of the pyrolysis distillation process affect the yields presentation of the metal removal and sulfur from the resulting liquid fuel? How does coal activated carbon concentration and pyrolysis distillation temperature affect the liquid fuel produced using the response surface model? Research objective: to know the ability activated coal as absorbent and carbon catalyst in the pyrolysis distillation process. And the second one, to optimize the recovery through simulation activated coal dose and pyrolysis distillation temperature using response surface model. Significance of research. Of course, this is to support the world agenda sustainability development goals. To contribute to overcome environmental pollution caused by the used engine oil, to contribute to the improvement of the derivation of coal product, and to produce environmental friendly alternative liquid fuel for the needs of small and medium industries which depend on fossil fuels. Research methodology. Strike or focus on the research objective. In this case, lowering coal, it was crushed and after that carbonized, screened, activated to develop lowering coal as activated carbon that can act as an adsorbent to heterogeneous catalyst. Activation tests was conducted using iodine number test as shown in figure 1. And the next step was the experimental pyrolysis take to obtain the optimized data using the response surface model RSM. The RSM model was used to obtain percent yield and percent metal sulfur removal. It's shown in figure 2. This is the figure 1 experimental activated coal. How to convert lowering coal to be activated carbon by through crushing, carbonization, chemical activation, using by aqueous and metal, drying, and after that the physical activation, and we find the activated carbon, create the activated carbon. And next, the research methodology about the response surface model setting the desired variable is temperature and those in the design RSM enter the lowest interval value and highest temperature variable 300 degrees Celsius until 400 degrees Celsius and enter those activated call in interval value 5% and 15%. After that, select the desired number responsive model and yield in the RSM column. Suggest the column above in the slide, and then the figure 1 experimental RSM, the figure 2 experimental RSM. Result and discussion. An initial investigation is first carried out to ensure the class of the core raw material used. The result of the analysis showed that calorie value of the coal used 3,804 kilocalorie per kilogram, which indicate the coal is in the low rank class. The result of which, as shown in table 1, we can see the number of iodine activated coal more highest than the standard requirement minimum 750 milligram per gram, and then this research find out the result 1163.51 milligram per gram. And then table 2 describe about the initial used engine oil, where used engine oil raw material testing is concerned in testing the metal content in used engine oil and sulfur content data were tested. The resulting of which shown in table 2, we can see metal and sulfur total 5,598 ppm. But we can find the chromium, we cannot find the nickel, we cannot find the tin in the used engine oil. And then this is the data by response surface model. Based on the table 2, in this case, there are various optimal conditions, so determine of optimal condition will be done based on the amount of sulfur and silica that are successful removal. With RSM simulation can be predict the optimum condition that can achieve, can be predict. The result shown is figure 3, 4, and figure 5. This is the figure 3, figure 4, and figure 5. It can be seen that removal reaction yield are directly proportional to achieve. Can compare the carbon ratio, higher removal, and red increase yield, but they depend on the operating temperature of the pyrolysis purification process. Increase the temperature can increase yield, but decrease removal. Removal can only be calculated by using quadratic surface model, that is figure 3, and yield distribution can also be using two models, linear surface model and quadratic surface model, for the figure 4 and figure 5. The result of optimal conditions submitted by RSM, the study, one prediction, 3 results. And the one is the best selection. The number 1 is the best selection. Based on the recommendation of RSM, the best operating condition for pyrolysis distillation calculation were the carried out to obtain the data, the presentation of metal removal and presentation of product recovery. The data obtained from the validation process is shown in table 4. You can see in table 4, it can be seen that the prediction made by RSM are not much different if the pyrolysis distillation process is carried out with the validation experiment. This measurement was carried out to determine the category of the pyrolytic product produced. The result obtained show that the product falls into the kerosene category, as shown in the table 5. You can see in table 5 the API degree kerosene with the handbook of petroleum product analysis of GEM despite as the reference. We can see the result product. Our result product is we can find the degree of API is 45.66, and then for the reference degree API kerosene is between 52 to the 40. In conclusion, the result of the study indicate that activated carbon produced synthesis from the low rainfall has the potential to be an absorbent and catalyst. As seen, the absorption capacity based on the unit number of 1,163.51 milligram per gram, exceeding the minimum limit of the 750 milligram per gram, and that is indicating the active surface area is very good. Based on the RSM recommendation, an experimental verification study was conducted. The obtained yield is 88%, removal is 77.50%, at the temperature of 416.54 degrees Celsius, and activated coal dose 12.87%. The pyrolysis product of used engine oil was obtained the API degree of the 47.66, so it can be compared with the kerosene. Thank you very much.